Hello students, today we are going to continue with the same topic, the moment of inertia. We already saw the two theorems, perpendicular axis theorem and parallel axis theorem. We already saw this one, you saw the derivation. So a quick recap about what is this, how to do this one. Suppose if you have a big body like this and this is the center of mass, and usually it is very easy to rotate a body along the center of mass. Along the center of mass, if you rotate, it will be very nice. So put a axis along the center of mass. That is the easiest thing to do. But if you wanted to do by choice any other axis parallel to this one, you make a axis parallel to this one, and by choice you wanted to make this whole body rotate along this particular axis. And this axis is already in a distance of a from the center of mass axis. Then the moment of inertia along this one, the moment of inertia along this particular thing, I is going to be equal to, the formula it makes it like this, it is going to be equal to I of center of mass, the moment of inertia along the center of mass, plus the entire mass of the body into a square. The moment of inertia of this particular line I is going to be equal to I center of mass, the moment of inertia along the center of mass, plus the entire mass of the body and the square of the distance. So this is the basic thing of parallel axis theorem. The same way it could have been already said in the derivation also. Now what is perpendicular axis theorem is? Suppose there is a body like this and it has a perpendicular axis like this, and it revolves. When it revolves like this, and you know this perpendicular axis, like if it is going to be IZ, so you know this IZ, what it is. Now you can make an axis like this, and you can make an axis like this also. So like this, and it makes it like this. So once you make like this is X and this is Y. So along the y-axis, if it makes to rotate, and along the x-axis, if it does, the same body also rotates. If the body rotates like this along x-axis, if the body rotates like this along the y-axis, then the moment of inertia along x-axis plus moment of inertia along y-axis is equal to moment of inertia along the z-axis. So Ix plus Iy is going to be equal to Iz. If in case you are able to find out the moment of inertia along x-axis, this is Ix, and in case you are able to find the moment of inertia along the y-axis, if the body rotates along this particular y-axis, you add both of them, you will get automatically Iz. These are the two important axis theorem. If you already derived this one, we have found how it is. So we'll try to move forward to the few other applications of this, where all it will be used. So hope you got an idea about why there are two theorems, because parallel axis theorem will go along any parallel axis here. But sometimes, not all the time it will work like this. In case you are able to find a value for the perpendicular axis, right from center to the top, if it is there, you wanted to find out that particular thing, then you might have to go to the perpendicular axis theorem, right? So another important observation I would like to say is, now in the beginning itself I said there is a center of mass of a body, this is center of mass, and when you make a body to rotate along the center of mass, it is the easiest thing to do. The same body, if you make it to rotate along the tangent, then the amount of distance will be too high. This distance will be less. This will be R dash, you can say. The more the distance, more will be the moment of inertia. Moment of inertia will be more. It is Ia is equal to mr square is the formula. It will be more. This will be definitely higher. Whereas moment of inertia will be less for this particular thing. Because the radius is more here, radius is less here. So always, whenever the axis is defined at the center, the moment of inertia will be much less, and it will be easy to rotate, and long time it will rotate. For this, you give a force, maybe it will rotate only for 3 times because the moment of inertia is very heavy. Whereas here, you rotate, it might rotate for 10 times also because the moment of inertia is less. So, even in your schedule and in your 11th standard, as you are moving forward, I already said in one of the very beginning, I said define your center. You define a center, you are very balanced, you will be able to go on for a long time. Why is that concentration is very short for you? You are unable to concentrate beyond 15 minutes, 20 minutes. You wanted to study for 1 hour, but you are unable to concentrate. The rest of the 45 minutes, it becomes a waste. You just concentrate for 15 minutes. Why it is? Because your whole thing, it is not you have not put the axis in the right place. Suppose you are having a cycle wheel. The cycle wheel, if you look at this one, its axis is exactly at the center. Spokes are all there. Have you seen that one? Try making a cycle and shift it little bit away from the center. If this is the center, little bit away from the center. Now you can look at this one. This is more and this is less. Then what will happen to the cycle? The cycle will start going up and down, up and down. Have you seen that one? That will make it very heavy. It will not be able to, because the center of mass is different and the moment of inertia is different. It is going on a roller coaster ride then. Defining the center and keeping the balance is so important in life. If you want to have concentration properly, I would say reduce other activities, which is apart from studies. You can do activities. You can go for cycling. You can watch some games or anything. But it has to be in a balance. You cannot keep on doing something else for a long time. If you are watching something which is obnoxious and it is not good for you, you are going to definitely not define a center properly. God will help you to define the center. Your life will be in balance. You can run smoothly for a long time. You can keep on going ahead. Here I said already it will go on for a long time because it is life is a different center. The once you dislocate little move away from the center also, it will really have it for you. Here it's not going to be smooth ride. So imagine if you put your axis in the last end and then the cycle is trying to go around. It is such a difficult thing, it will be there. So I would encourage you to sit quietly and retrospect your life. Where are you wrong? Where is your time misplaced? Where is not the balance is there? Try to look at it. Are you too much into constantly texting? Are you too much into some games? Are you too much into some viewing? Or are you too much into something else? Please take a pass. There's 1 week more. Examination will start. You need to prepare well. Keep it in a balance. So it's so important. I will continue to move forward about this theorem. We are going to base our applications on these 2 theorems, perpendicular axis theorem and parallax theorem. Right? Now, you're going to turn to page number 424. Look at this one. Formula of moment of inertia of certain regular bodies. So the first regular body is going to be moment of inertia of a uniform rod. Moment of inertia of a uniform rod. So how that one works? So if you look at a rod like this, maybe a kind of a scale. This is a rod and L is the length of the rod and this is the axis. This is the axis and it's going to rotate like this. Right? So if this is the axis and the rod is going to rotate like this, the moment of inertia is already given here as ml square upon 12. This is the standard one. It has already been derived and given. Please memorize this one. Memorize this one. This is A part, axis along the center. Now B part, axis along the edge. Axis along the edge means if you have a scale, the same scale like this, same length, but the axis is put like this. This is the axis. Now tell me which will have more moment of inertia. This will have more moment of inertia, this will have more moment of inertia. Already I said, more the distance from the axis of rotation, more will be the moment of inertia of this one. But now we need to find out how much is this moment of inertia. This is already known. This is the center of mass. This is the center of mass, we already know this one. And this distance is L by 2. Now it looks to us, it is a parallel axis theorem. You can use a parallel axis theorem and find out. Alright. So, according to parallel axis theorem, so what is the parallel axis theorem? I is going to be equal to I center of mass plus m a square. A means the distance between them. So let us try to put this one. I center of mass is ml square by 12. This is what it was already given here. I center of mass. This is center of mass. For the center of mass only it is 1. This is the center of mass. It is already ml square by 12. ml square by 12 you got to put plus m into what is this distance? This distance is L by 2 the whole square. A is this distance. So that is I. Solve this one. You will get the answer here. So it is ml square by 12 plus ml square by 4. So what is the average? Sorry, the LCM. LCM is 12. So ml square plus. So this one is going to be how much it is? So you will get here as 3 ml square, which is going to be equal to 4 ml square by 12. Cancelling out, you will get here ml square by 3. Now what is ml square by 3? If you rotate like this in this axis, so the moment of inertia is going to be equal to ml square by 3. Same thing if you rotate here. Now look at this one. The center, it is ml square by 12. So ml square you divided by 12, it is a very less amount. Ml square you just divided by only by 3, there is a very high amount. This is much higher. So that is the thing you have here, right? Now we'll go to the next one. We'll go to the another one. Moment of inertia of a rectangular lamina or a plate. So second one, moment of inertia of rectangular plate or a lamina. This is A, this is B. So how this is measured here is I is going to be equal to m into L square plus B square divided by 12. So that is the trick here. There is nothing else. We are not having any kind of parallax theorem here. So you can just leave it here and you can keep doing this one. Even if you wanted to calculate something else, you can try also. We'll go to the third one. Moment of inertia of a ring. So a ring will be like this. And this is the radius of the ring. So A part of it along the center. So along the center, if it is there, what is the moment of inertia? I is going to be equal to mr square. This one you need to memorize. That also you need to memorize. I is equal to mr square. Now we are going to see many other moment of inertia. What will happen along the side, along the diameter? You can keep finding it out, right? So what will happen here? B part along the circumference. Along the circumference perpendicular to the plane. That means the ring is like this and you want to rotate like this. And we already know this was the moment of inertia of the center of mass. This is center of mass. Moment of inertia center of mass is already mr square. We already saw this one. What is this one? We need to find out. So go do the same thing. I is going to be equal to I center of mass plus ma square. So what is this distance? This distance is going to be radius itself. From here to here is radius only. So it's going to be equal to I center of mass is mr square plus this is also mr square. So I is going to be equal to 2mr square. This is along the circumference. The next one is C part along the diameter. Along the diameter. What does diameter means? If this is a ring and you rotate like this, along the diameter this whole thing is there. Not in this way. It is not this way. This is along the center. Now you are talking about the across. Right? You can also make it across here also like this. Either it rotates like this or it rotates like this. Okay. Now how to find out this one is, we know I center of mass is going to be equal to mr square. ICM is going to be equal to mr square. We have to use the perpendicular axis theorem. Using perpendicular axis theorem. What is perpendicular axis theorem? So I center of mass is going to be equal to Ix plus Iy. Alright. Now this one and this one will be same. So it's going to be 2Ix also you can put, because Ix will be equal to Iy. You can put twice. This is going to be equal to mr square. So what is only Ix? Is going to be equal to mr square divided by 2. This one goes down. So that will be the value here. If you want to find out the value of this along the diameter, it is mr square by 2. Along this diameter also it will be mr square by 2. Iy also it will be equal to mr square by 2. Because we got mr square, the perpendicular one we know, we have got the other two along the diameter. Okay, this is for a ring. This entire thing for a ring, 3 cases. Now we will go ahead and I will ask you to do for the disk. Please find out all the 2 cases. Next one is 4th one. 3rd one is ring, moment of inertia of a disk. What is disk? Disk means the entire part, it is a solid inside. So everything is there. Inside the metal is also there. So whenever the disk is rotating, the moment of inertia along the center of mass is going to be equal to mr square by 2. Right? Because the mass is all uniformly distributed, it is mr square by 2. But if you look at this ring mr square only. But disk is mr square by 2. There are so many mr square is coming. You need to be very careful about how it is. Okay, I will later on I will make a tabular column and show. This is mr square by 2. This is along the center. This is A part. B part along the circumference. Perpendicular to the plane. What does that means? So take it like this. Now this is perpendicular to the plane. So I is going to be equal to, so you have to take the, again the same theorem, I center of mass plus m a square. I center of mass is mr square by 2 plus this is also r, so it's going to be mr square. So it's going to be equal to 3 by 2 mr square will be the value here for this value. This is along the circumference. C part along the diameter. What does diameter means? If the disc is like this, if it goes this way, what will happen? So for that, again you need to go like this, and it could be made like this. So Ix plus Iy is going to be equal to Iz. So Iz is going to be equal to Ix plus Iy. Here it will become 2 times of Ix because this one and this one is going to be same. 2 times of Ix is going to be equal to mr square by 2. This Iz is already there, mr square by 2. That one is there. So what is Ix is going to be equal to mr square by 4 will be this. Right? So we've got quite a lot of them. Disk we have found out, ring we have found out, uniform bar we have found out, right? And a few other things, just a face value of it we will just write down and finish, right? Solid cylinder, fifth one, solid Mi of solid cylinder. So if the cylinder is there, and you find this is the axis could be, or also it could be like this. This also could be an axis. Okay. So whatever the axis it could be, you can find out. Right. So this one is going to be along the axis perpendicular to the length. Along the axis perpendicular to the length. So we know this particular thing. It will be the length is here, and this one is the radius. And the entire thing has a mass m. So the moment of inertia for this one, it is going to be equal to m into L square by 12 plus r square by 4. This is the value here, r square by 4. So please try to understand this. Now what happens if it is going to be the moment of inertia along the center of the cylinder, B part, along the center of cylinder through the height. So through the height, along the height, if it is there. This is a very common one. Now this is quite interesting, very very interesting. Look at this one. Even though it has a height, maybe height or length, and it has a diameter or radius r, remember this moment of inertia is same moment of inertia of a disk. Same moment of inertia of a disk. What was the moment of inertia of a disk here? Moment of inertia of the disk was mr square. Suppose this disk has had a kind of a bottom one is there. Suppose it had a height. But it still will not capture. It will not capture. It is only from this one only. So what if the cylinder is a little more, depth is more, height is more, it is also not, it will not capture. So the very thin disk, thick disk, very thick disk, everything is same. Everything is same. So even though it is going to be huge, thick like a cylinder, I will be equal to mr square only. A height will not be included at all. So moment of inertia along the center of a cylinder through the height, along the height, through the center of a cylinder and through the height means mr square only, no height parameter will be there. But here in this fashion length parameter will be there. Okay. So sixth one, moment of inertia of hollow cylinder. What will happen to that hollow cylinder? So you find a cylinder like this. So you have this cylinder which is coming here. There is a hollow in the brittle, and you can have axis here. So you have a smaller radius, you have a bigger radius. So the smaller radius you can call it a small r, and the bigger radius you can call it as capital R. And the entire thing has a mass of m here. Now which axis you are rotating? Which axis you are rotating? You are rotating along this one. You are rotating along this one. This is the length. So if that is the case, how it will be? So about its geometrical axis. If it is about the geometrical axis, it is going to be equal to half into m capital R square plus small r square. Alright. So this is going to be geometrical axis, means it is going to be like this. It is going to be like this. I think this is what it is. Capital R square, small r. This is small r, this is capital R. And this formula will be like this along the geometrical axis. This is A part. B part is this one, perpendicular to this one, along perpendicular to the length. Right? Passing through the center of mass but perpendicular to the length. How this will be? That will be a bit difference will be there. I is going to be equal to m into same L square by 12 earlier it was there, plus R square minus plus small r square upon 4. So this will be the value of this. Okay. So this is a hollow cylinder. Now we are going to almost end the last one, solid sphere and hollow sphere we need to see. So there are the last two things are there. So what happens to the moment of inertia? Seventh one is about the moment of inertia of solid sphere. So if a sphere is there and it is a solid one, and you are having along the center of mass, this one rotates. If that's the case, I is going to be equal to 2 by 5 mr square. Alright, and the same cylinder, if you are going to have it, this is the one, and you have it along the thing. A part is along the center, B part is along the tangent. If you are going to have it along the tangent, what will happen here? This is the entire thing. So you have already this one, the center of mass is already there. So it's going to be equal to I is going to be equal to I center of mass plus it is going to be equal to mr square. So it is going to be 2 by 5 mr square plus mr square. So it becomes 2 by 7 mr square will be the answer. So it's going to have a small change in this one. Okay. Now the last part, we will just finish here with the last part, which is going to be holosphere. What happens to the holosphere? Moment of inertia of a holosphere. So this is the 8th part is there. Now 8th part is the holosphere. You have a smaller sphere and another concentric bigger sphere is there, and there is a kind of an thing which has small radius and then bigger radius, and it goes through the center. How it will be? So it's going to be I is going to be equal to 2 by 5 capital M into r to the power of 5 minus r to the power of small r to the power of 5 r cube minus small r cube. It's looking quite strange. It's different. It's okay. So this is the way it will be. This is a holosphere. Okay. So this is the different ones. Alright. Now if you are going to have a spherical shell along the diameter, so if you wanted to make it as a diameter, then it will be quite different. If you are making it along the diameter, the hollow shell itself, okay, so then that's going to be only I is going to be equal to 2 by 3 mr square, okay, along the diameter. So I will quickly run through all of them, the 8 ones only along the center. Rest everything you can find out yourself, right? For the rod, if it is like this, so ml square by 2 by 12, and B part rectangular lamina, if it is like this along the center, ml square by 12 plus B square, it will be like this. C part ring, so if it is a ring, now it's going to be equal to mr square, right? If it is D disc, so if it is a disc fully, so it's going to be equal to mr square by 2, and then E part of it is going to be, if it is going to be a cylinder, so how it will be? So with the length here and radius here, so it's going to be equal to m L square plus R square divided by L square divided by 12, R square divided by 4. Okay. So the F part of it, hollow cylinder. So you find this is the one, and the bigger one is like this. So you have the small radius and the bigger radius, and it is rotating like this. So it makes it as I is equal to m times of L square by 12 and R square plus small r square by 4. This is the value. L square by 12 plus this is going to be the separate value here. And then G, so it is a solid sphere. So it's going to be a sphere. Then it's going to be mr square. It is 2 by 5. And it is hollow sphere. So it's going to be equal to, a bit of difference is there. So about the diameter and about the spherical shell. So it's going to be 2 by 5 m. So r to the power of 5 minus r to the power of 5 upon capital R to the power of cube So that's the way in which it is. Okay. Alright children, so you've done quite a lot. So if it is a thin shell, it's going to be also equal to 2 by 3 mr square, also it is there. Okay. So you can note down all of them, memorize every formula, it will come in the examination. How can I memorize everything? If you know only these things, you can try to find out any other format using the theorems. Alright? Alright, thank you.